about you. So I think that as much as, and in fact, there's another interesting part of this arms race, which is, if you think about this, the most adaptive, evolvable system is one that has the most level of top-down control, right? If it's really easy to say to a bunch of cells, make another finger, versus, okay, here's 10,000 gene expression changes that you need to do to change a finger, right? The system with good top-down control that has memory, and we need to get back to that, by the way. That's a question I neglected to answer about where the memory is and so on. A system that uses all of that is really highly evolvable, and that's fantastic. But guess what? It's also highly subject to hijacking by parasites, by cheaters of various kinds, by conspecifics. Like we found that. And then that goes back to the story of the pattern memory. In these planaria, there's a bacterium that lives on these planaria. That bacterium has an input into how many heads the worm is going to have, because it hijacks that control system, and it's able to make a chemical that basically interfaces with the system that calculates how many heads you're supposed to have, and they can make them have two heads. And so you can imagine that if you are so you want to be understandable for your own parts to understand each other, but you don't want to be too understandable because you'll be too easily controllable. One of the ways to start thinking about bioelectricity is to ask ourselves, where did neurons and all these cool tricks that the brain uses to run these amazing problem-solving abilities on and basically an electrical network, right? Where did that come from? They didn't just evolve, appear out of nowhere. It must have evolved from something. And what it evolved from was a much more ancient ability of cells to form networks to solve other kinds of problems. For example, to navigate morphospace, to control the body's shape. And so all of the components of neurons, so ion channels, neurotransmitter machinery, electrical synapses, all this stuff is way older than brains, way older than neurons, in fact, older than multicellularity. And so it was already, even bacterial biofilms, there's some beautiful work from UCSD on brain-like dynamics in bacterial biofilms. So evolution figured out very early on that electrical networks are amazing at having memories, at integrating information across distance, at different kinds of optimization tasks, image recognition and so on, long before there were brains.